So we will present our connector. Our approach has been slightly different. The idea is to have a connector that is made of a set of tools. We must say that we are in the Universidad Polytechnic, but we are in telecommunication engineering school. This means our background has been video conference and a lot of systems where you have a lot of standards and problem things of interoperability. Our main goal is to develop a set of different tools that could be used for implementing the data spaces, but also to check and to manage to make interoperability between different data spaces. In previous talks last year, we presented data space definition language. We don't repeat this. And we are now agentic because we have different languages in the middle connecting our things that could be generated right now with LLMs. This means that we are very close to have a simple prompt to define different things. So our main mission is to create everything, keeping in mind that ODRL and formal methods and sovereignty should be something that will be in the center of all of this, building trust. Yesterday, Antonio had also talked about a similar approach about this, and we believe that this could be only done via open source implementations and properly specified open interoperable protocols. So our key is that we are able to make different data spaces interoperable between them. As I said, we have different domain-specific languages that were presented the other year, and that we see that we can generate with LLMs and even with SSLMs. So this will be the glue code that can be generated by configuring infrastructure. Also, we are teaching big data, so later we will tell about how we can generate also the glue from the data lake to wherever you can send via Apache Camel DSL. So our final goal that still has not been achieved is to develop any kind of data space in 10 minutes with a prompt. And everything should be done by the agent, and it should rely on a lot of libraries of how the different things work, and the DSLs should be generated in more or less automatic way.
So in this case, we are going to present all of the part of the connector that we have. We have been developed many things regarding this connector, and also provide a user interface for trying to deploy in an easy way all of the part that you want to have for data sharing. In this case, our connector is based on the DSP developed by IDSA, and also we have the catalog with DCAT and ODRL, also the contract negotiation and the transfer. That is the definition that we have in the data space protocol. In this case, for this connector, we separate two main things. For one side, we have the agent that is in charge of all of the part of the contract negotiation transfer and also the catalog, and the other part that is one component that we call the data space authority. In this case, the name of the software is Heimdall. This is in charge of manage all of the things regarding the credential and all of the presentation that we need inside of the data space. And more or less we have this picture in where we have the provider, the consumer, and one authority. The authority is who is in charge for managing all of the interaction with the verifiable credential, provide the verifiable presentation, and create the trust environment between the provider and the consumer.
One key is that we have managed to get the certificate that is in Spain to pay the taxes, so anyone that pays taxes can have a data space.
Yes, we provide a very open interface in where we can use many types of certificates for being generated the credentials. As Joaquin said, one of the Spanish government that we have.
Everyone have to have, all companies and people have to have it in Spain, so they don't require any extra.
In this case, we have the authority as a central point in this deployment, but we also have communication with Gaia-X and all of the part of the trust framework. In this case, we can use the authority for managing all of this interaction, but we can delegate it also to Gaia and act as a proxy. We basically build a dual stack for providing this type of interaction and don't separate all of the ecosystem that works with another type of things. In our implementation, we base all of the implementation for the data plane based on DSP, but for the control plane for the DSP. But for the data plane, we develop something called programmable data planes. And we can choose how we can, in this case, transfer the things depending of the protocols that we need to manage in the lower level. For example, more of the cases you need only pull and push, but you can also have a streaming that comes from different sources like Apache Kafka or many other data sources that came in from all of the ecosystems in big data.
Yes, the key here is that we are able to connect from the things that producing data and consuming data using the real industry big data tools. And this we have the generation of the code of the glue automatically. This means that anyone that is using big data can use a data space in their workflow without changing any line of the thing they have. All the code will be automatically generated and will be connected. Also, it's quite key that we are using now Rust. Also, we have parts that it will be in Go. But everything should be quite efficient, quite small, and should be deployed in a Raspberry Pi in Edge. And we have two modes of compilation. We can mode how the modules are as a microservice, or in case you have to develop for the Edge, can be a simple monolith.
We have many interfaces that you can interact in many ways. We have a graphical interface, but also we have an API for doing all of the tasks automatically. In this case, we have the many interactions between consumer provider and also the authority and define this flow. This flow is using some protocol called GNAP, Grant Authorization and Negotiation Protocol. This is a protocol that substitutes OAuth 2 and we have developed an extension for making all of the verifiable presentation. We already present this in the patch TextX, so we are this in some paper that we can.
Yes, the key is that OAuth 2 is well known to have some attacks. These attacks are quite complex. GNAP is a complete piece, the replacement for it, and it simplifies a lot the workflow. We have developed our workflows for obtaining the grants and having the trust, and uses the same pieces in a different way, in the way that will be in the future all over internet.
In this case, we have the two parts that I explained before. We have Heimdall that communicates with the clearinghouse, manage all of the things in some way of governance for managing the credential, and also can emit some verifiable credential. And the DS agent, the Eunomia agent, manage the contract negotiation, the transfer, and also can act as a proxy for all of the part of the governance that we need inside of the ecosystem. So we have right now some demo, but before I want to put more or less some starting point that in this case in the demo you will see the onboarding part, how we can get the credentials through Heimdall, how you get the verifiable credential, how you present the credential, and how you are in the onboarding in the data space.
Yes, one key is the usability. We all know that you can enter and see the details, but nobody wants to see the details, nobody wants to see the QR. So we have everything is hidden. If you want to go to the QR and you want to go to the credential or the JSON, is there, but normal people don't want it. All our experiments can show that says, why I have to do this? I just want a button to say login and forget. That's what we are going to show. Everything is there. We have simplified the workflow. If you want to do other workflow, are there. But usability is key, and this is the way that people will use this.
Okay, in the demo we will see two main parts. We have one consumer for one side, and in the part of the consumer agent we have a metabase only for visualization, and you can see how the data is transferred. We have in another side the Eunomia provider or the connector provider, in where we have some external endpoints that injects all of the data in that part, in the part of the provider, and also we have the authority for managing all of the credentials. We will see the onboarding part and also the transfer between the consumer and the provider with that credential using, in this case, the graphical interface. In the demo, we will see all of the interaction that we have in the DSP. We will have the contract negotiation, defining the contract with ODRL, also the agreement that we have once we have signed the contract, and finally, the interaction between the transfer request and getting the final data from the provider to the consumer. And we will start with the video, and as you can see, this is the interface of Metabase. It's a dashboard for visualize all the data that we will have. We have, in this case, three actors. This is the consumer. We have Heimdall, that is the data space authority in our environment. Also, we have here the consumer that is not still in the data space, that needs to do the onboarding. And finally, we have the provider. The provider is already on board. So we have one part that we need to first authenticate using the verifiable credentials for start to make something in the data space. As you see, you can see this is not in the data space, so we have to join the data space. We have here a wizard that we can use for have a guide for get first the credential. So we choose the data space authority, and we can select what type of credential we will have for the data space interaction inside of this. We have the Gaia-X credentials, and also have the generic credential that we use with the Spain certificate that
but if you don't want, you just say next, next,
exactly.
Next, and works.
In this part, we have one checkbox that indicates if you want to use the QR code for getting the credential, but in this case, we use the machine-to-machine interaction. We don't have to get the scan
the QR, the scan, or cut and paste, or whatever.
Yes,
yeah.
go directly. In this case, I have the credential, but the credential is not presented yet. So we need to present the credential to the provider, and this is the other interaction that is another wizard that guides you to request this connection. You select what is the provider that you want to, in this case, present your credential, select the provider, and then you can onboard with that provider.
But again, you can say next, 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 and forget about details.
Exactly. In this case, you don't need to scan the QR, and you are already authenticated in a data space, and you can see the catalog of that provider, and you can perform all of the different tasks inside of the data space. We have here the catalog, also the data sets. In this case, we will
the Costar is the project that we are deploying.
We will work with this data set. We have some distributions, and also we have some ODRL policies defined inside of the platform. So in the moment that you choose what that data set and what policy you agree to use, you have to perform a request that is for, in this case, creating the agreement. This is the part of the contract negotiation. You request a contract negotiation, you have to go, in this case, the provider can see what contracts are requested. The provider is able to accept or deny the contract. In this case, we agree the contract, and we go back to the consumer, and the consumer will have the contract, in this case, done, and it generates an agreement. In this agreement, we have all of these things, and we can start the transfer. In the transfer, you have the distributions that you have in the data set. Select in this case, the distribution, pull or push, the two basic cases.
But could be other tools, yeah?
Yes, we can use the pull interaction, request, in this case, transfer. And when you start the transfer, you will see the details, and in the details you have the URL or the endpoint that you can use for consuming this data. In this case, as is a full scenario, we have here the URL that you can use to, in this case, consume, in this case, for Metabase, and you will see how in Metabase you have right now the data that was in the provider only, but right now is also in the consumer. This is a very fast demo. Is a very easy case, but covers a lot of cases inside of the data space. But we have, as you can see, we have the whole components to make this interaction, and we have here the software components to extend this for more specific cases.
Yes, the key here is that we have shown that we can do a lot of things, and we are trying to develop new extensions and new things here. As I mentioned, it's a completely written code without taking code from the usual Eclipse things. Probably we will open source as Apache project. All the code is from us, including the part of the identity, all of this. We are writing our own libraries because we want to contribute and make new standards. It's not only that we want to implement data spaces, but we will contribute both on trust and also on communications and in different layers. More of this come later. So, as I mentioned, we are having a very complex ODR execution approach. This has been speech before. We have transpilation, that is to change from one language to another. In our case, the reback, we are using OpenFGA, but we can translate this also to wriggle out the other things. And to analyze what is inside the things is using the Apache Flink complex event processing. And we have discussed before, we have to go through a process algebra with TSP. We have a compiler to go to routines of the specification. It's not to compile the URL, it's to compile the specification that is able to detect these events. And as I mentioned, with model checking and TLL+, that is the Leslie Lamport import for this, using his language, we can use of this. In this case, will be the implementation of the profile that we have seen before. Here, this project takes the implementation, and inside W3C, we are just specifying what it should be done or should be considered. We connect to the LLMs. As I said, everything in the middle uses the data definition language that we presented a year ago. The only change is that part of the things need a YAML for information, because some of the APIs we want to make them the same way that is designed the Kubernetes one, that is declarative approach. In declarative approach, you do not go through different steps, but you upload a definition on how the infrastructure should be. This is the way that Kubernetes behaves. And so you put the YAML, but also you need a workflow, because as we mentioned, each of the data spaces are slightly different. So each step should go in a list. We have chosen PDDL because it's written in Lisp, and LLMs hallucinate less for our experience. Lisp and Go are the language where there is less hallucinations and less problems with this. This means now we are using Gemma 4 that is integrated in our, is deployed as a container, and this means that we are not communicating to any LLM outside the infrastructure. The key is also that we adapt how we connect to the different data sources and the data consumers. Right now you have to write this by hand, and we are choosing Apache Camel, because Apache Camel generates this infrastructure using also YAML definition of the infrastructure. Again, we are generating this YAML definition, and we can deploy automatically the connection, all the injection, and in the case of the injection to the data space, but also connected to any kind of infrastructure. And we can connect the data plane automatically to all the big data protocols that is used right now. Especially, we are telecommunication, and we are very scared of the performance of moving data of some of the data spaces. If you use a REST API, you can take HS to move a gigabyte or a terabyte, and there are now protocols that are able to do this at high speed. This means that we are using this kind of protocols. In our case, is the Apache Arrow 1, and we are able to do this. And the enforcements here will be also used Apache Flink in the connection of the data. Inside the data, we are able to make enforcements if some data can flow now. So, as we want to have a conformal test suite, and we are working on this, not in these components. We are using the tests that are defined in the interoperable, Europe compatible, favorable. We are right now with the compatibility with the data space protocol, but we are trying to define an advanced data space protocol because we see that there are holes that are not specified there. But we want to do verification and validation of the connections and see that everything interoperates and helps also having dual stack implementation of this to serve as a gateway between data spaces that could be implemented in different technologies. So, we've foreseen that advanced data space protocols should have 7 layers. Well, I come from ISO, so I put 7. That's but we see that this is not properly cared. First, communication. Communication, you have to deploy the infrastructure behind a firewall. You don't have the protocols required to open in the firewalls. As we are from video conference, we know very well. And you have to define how to open and close the usual firewalls if you are not deploying the data space outside the military zone. If you have your infrastructure and you have to protect your infrastructure, you need to deploy the component in different parts of the infrastructure, and the security should be for that. The data should have advanced interconnection, as I say, very high speed, and the usual big data protocols for this. The other layer will be the trust and the ODRL that need information to be changed that the things are properly work. We are looking for open specification for governance and data lineage. There are some specifications, but we need to specify also the protocols of how this is handled. Probably we contribute this to the ATF. We know that there should be payment and other consideration, payment you interchange or whatever. This part is not properly done. In another things they are using a proprietary APIs, like it's these APIs for business and markets. We need a layer where we have trust and self-sovereign identity properly used. With more of this later. We want to use the self-sovereign identity using the distributed part. We don't want the use as it is centralized. An advanced control plane where you can do this very general, thinking that there could be agents. I mean, when I'm talking of agents, I am talking of agents that could be upon all of this. So the advanced control is not only for people or program, but also for agents that want to interact on these things. We foresee a legal layer that will be out of this, but we don't enter this. So we want to have a complementary goal with an advanced deployment. We want to be able to automatically deploy this on Kubernetes or different types of infrastructure. We are working and trying to see if there are different protocols that could be used for the catalog implementation. Basically, they are in distributed system in catalogs, or you have protocols for copying things, or protocols for distributing the queries, then you have to wait for all the answers. This are different protocols on this, and we have to see this. We are working with the Persona project. The Persona project is trying to have a distributed model of trust on trust trees and graphs, and being able to relay on agents. We want to use this to relay on data spaces, and we want to simplify the API expose and have it in declarative mode, as I said, similar to Kubernetes and all these kind of things. So this is more or less the layers. I tried to do it with AI. It's able to count to 7, just put 5 and put the others, but what? I didn't want to argue with the AI because this is the point. This is more or less the ideas that have been mentioned. There should be 7, but what? I don't know if you count those on the side, but you know. The idea is to have a network and connectivity plane where you can define all the connectivity related to firewalls and all this kind of networks and this kind of thing, that you know that is important in the end, especially for cybersecurity. We want to have a complementary goal with an advanced deployment. We want to be able to automatically deploy this on Kubernetes in all these kind of things. So We want to have achievement and protocols that are able to increase the cyber security of data spaces that in most cases is not taken care about. So the data plane is more complex because we want to have multiple protocols connections that allow high speed and also different things. The trust that we are working in different models connected to the URL, the governance that should have connections, an easy way to have this in a fully distributed way. This means that we want to consider when a data space takes input from another data space and the governance events should flow along of this. This needs to define probably a global data space identifier with different points of access that should be running all the time that the transfer is taking place. If this is one-time transfer, it's easy, but what happens if there is a streaming that takes years? This means that you have to keep some points years in order that you have to send the governance information. So, or if the point disappears, should be some kind of proxy that push this information. This is a problem that we are attacking, and we will see it. And the business part, that is not the one. So, our idea is that we will have Gaia-X things. EU data spaces could be Gaia-X or not. We are considering also China, which means that we want to achieve interoperation to the trusted data matrix, that the EEE standard. Probably there are others, and we will try to build bridges of them. And the idea is to have, especially the trust and the different models that are able to interoperate maybe with the WTC, the ATF that we are there. And the key is also the Global Digital Compact, that is an initiative of the United Nations about having a global and common identity system for all the people in the planet. It's related that if have an identity on internet is a right that you should have of this. So probably we will have a trust model with FTSE that we are discussing also with Christophe and that everything match and is connected. Our idea is that it's something like the Federation of Star Trek on this. This is something more personal. I hate the RDF implementations of Graph. I don't like Java. I don't like these tools. So we are trying to build different ones. I don't know if we succeed or not, but at least we are trying. We have the different problems, especially with shackle. The shackle verification tools right now for us are not the right ones for this, and take ages, take a lot of memory. So we have discovered, you know, that a graph is a matrix. So RDF is a matrix. So verifications on graphs could be math over matrix. This math is very big. You can use the tricks of having a sparse matrix that is how it's implemented right now for the recommendation models. And this is the advantages of being implementers of big data tools. So we want to have produce a shackle verification that is using matrix operation, not graph traversing in Java or wherever. Will be very slow to produce, but the key is that this operation with the matrix are very fast when you have it. So it's just to make transposition and a couple of things more, but it's very efficient. So we will try to produce a compiler with this. I would know if we will succeed on, for all the cases. For some cases we have been successful. We have a Go implementation that is using some sparse matrix implementation, and we hope to be able to substitute these different parts inside all of this. So thank you very much. Just to mention, we didn't have the slide, we call it Eunomia. The name of our projects come from the Greek goddess of the good law governance. There is another goddess for the bad law, but this is the one for the good. Yeah, that's it. In Greek, they have all the kind of things.
Yeah, thanks a lot.